or record the others that are not there. Can you see my paper?
Yes, sir.
Make
Yes,
sure
sir.
you've got your periodic table. We are continuing on the properties of periodicity as a topic. For each of the following, give the name of an element in period what? In period two. Huh? Period one is simply hydrogen and lithium. Period is going across. So period two, it means two shells. Huh? That's why it's called period two. All of them, they've got two shells, huh? Starting from lithium to what? To neon. Huh? Elements may be used once or more than once, or not at all. Huh? Clear? So an element that which is a gas at room temperature and pressure. Which one? You've got your period there, periodic table. Period two,
Fluorine.
chlorine. You said chlorine or fluorine?
Fluorine.
Chlorine. Is
Yes, sir.
chlorine in period two, guys? Is chlorine in period two? So that we correct him. Is chlorine in period two? How many electrons does chlorine have?
See, I said fluorine.
Fluorine. Okay, but chlorine is not
Yes.
in period two, it's in period three. Fluorine, I agree there. So we could write fluorine. What else besides fluorine in period two? Gas at room temperature. Give me all the gases. What else? Period two, gases. What else are the gases? Besides fluorine, which one is a gas at room temperature? Oh, you guys, do you have a
Oxygen.
oxygen is a gas at room temperature? Oxygen O2 which exists like this. Which one else is a gas at room temperature?
Nitrogen.
Nitrogen. That's what he said. N2. What else? Yeah, even leaving the neon, we said all group 8 are gas at room temperature. So neon is a what? Is a gas at room temperature. Making sense? How did you get that? Now let's go
Yes,
to the
sir.
next one. Which element forms, okay, which element, an element which forms an oxide that is a reactant in what? In photosynthesis. That is a reactant in photosynthesis. Which element? Reactant, it means when you are reacting. Huh? So which element?
Carbon.
Carbon.
Carbon. Huh? Because we say carbon dioxide plus water. Carbon.
Yes.
C. An element that is a product of photosynthesis. An element that is a product of photosynthesis.
Oxygen.
Oxygen.
Oxygen. Correct. Always exists as diatomic oxygen. Now, of course, if you write all, they won't penalize because they're talking of the element. An element that makes up approximately how much? 78% of the volume of air. Which one? From your EM, from your other subject, from your chemistry, from your biology, you need to know that 78% of the air, which gas is that?
Nitrogen.
It's nitrogen. Nitrogen makes
Nitrogen.
78%. Oxygen makes how much percentage? About 20 to 21%.
20%.
Carbon dioxide makes 0.04, some books say 0.03%. Then the small percentage is other gases, yeah. Group 8 and other small gases. Clear? Mainly group 8 contributes the smallest percentage to your natural air. Now, an element that has atoms which are full in its shells. Full in its shells means
Neon.
neon, which means it's
Neon.
complete. Neon there will be 2, 6, 8,
Okay.
complete. Clear? Your neon there should be Ne if I'm correct. Now, don't have a period table. An element which exists is both graphite and diamond from your covalent bonding. Graphite
Um,
and diamond, what is that?
Carbon.
It's carbon. Carbon has got two forms, graphite and diamond. We'll talk about it when we revisit the topic. An element that reacts vigorously with cold water. Vigorously, what is that? With cold water? We learned that. Are you in your period 2 then? An element vigorously, which one? With cold water? Yes, stuck. Vigorously with cold water, what is it? Vigorously with cold water. Which element? Oh. Hmm? Can only be lithium, huh? Because anyway, though it's slow, but I'm saying compared to your group 2 and group 3 metals. Remember, I said group 1 are the most reactive. Huh? By the way, what we mean, look at this. We said group 1 are the most reactive. Huh? Lithium in the group is the one that is not reactive than the others. Huh? But maybe what I never mentioned is that lithium, though it's slow, it's actually more reactive than group 2 metals, than group 3 metals, or than any other transition metals with water. Clear? Because we are saying group 1 is the most reactive. Clear? Which means even the slowest reactive metal, which is the lithium, is actually more reactive with water than your group 2 metals or your transition what? Your transition metals. Are we together? So it means lithium there. A soft metal, metallic element, which is stored in oil, what's that? That's easy. A soft metallic element, which is stored in oil. What's the answer?
Lithium.
Lithium. What did we say?
Lithium.
If you check your notes, we said group 1 metals are soft. And they can easily react with air, so they are always stored in a lab in oil. That's what we said. Oil prevents the seal, as a seal, if you're reading on lithium. Clear?
Yes, sir.
Now, give a formula for the compound that contains boron and oxygen. Now, go and check which group is boron.
Group 3.
Group 2, and what's the chemical formula? B.
Yes, sir.
So if it's group 2 is B plus when it gives 2 away.
Say it's,
Oxygen always accepts BE. Yeah?
So
I
it's
say
group
boron
three.
is group
It's
3.
group 3.
Group 3, you're
Group
not giving
3.
me
Yes, sir.
things, huh? So BR3 plus, like this. Huh? B3 plus, huh? Because it's group 3. Now what did you do? We say we do the crossing. Remember? So how many borons do we need? 2. How many oxygens? 3. What's the formula? Making sense? Now let's do the lithium. Lithium is group 1. So it forms a +1 ion when it reacts. Oxygen is group what? Group 5 non-metal. So it wants to accept 3 what? 3 electrons. Huh? It's easy for it to accept 3 electrons than to lose 5 electrons. Huh? Anyway, it's a non-metal, it accepts electrons, okay? When it reacts with a metal. So what formula do the crossing? What's the formula? Li what?
3.
3. We need 3 of them there. We explained the other day. Then we simply need, this is +1, we simply need 1 like this. What will be the formula of that? Let's see your chemistry. So what will be the name of this? What will be the name of this? Name? Can someone try? There's no harm in trying. What's the name of this? There were a few people here. What's the name of this? What's the name?
Lithium nitride.
Lithium. Lithium. Not correct. You have an idea. How many lithiums are there? 3. So what should we say? Try what? Try lithium nitrate. Try lithium nitrate. Anyway. Now let's look at the number 2 there. Rubidium is a group 1 element. Who is logging so late? Like, maybe tacos were having issues with this network. Okay, that's fine. Now, rubidium is a group 1 element. It has similar physical and chemical properties with other elements in group 2. Predict how many electrons are there in the outer shell. So how many electrons are there in the outer shell? 1 mark of rubidium. How many electrons?
1.
1, because it's group 1. Oh, group 1 should have what? So group 1, I think they have an issue with fiber link in Sherez from what one of the parents is explaining. I think they were online when we started your bio. Did you watch the videos for your bio? And wrote in summary notes?
Yes, sir.
Or you were
Yes,
now,
sir.
or you were playing? Predict one physical property of rubidium, which is the same as what? As other transition elements. Predict one physical property. What could be that? Which is the same. Group 1. What's the same with group 1? And we're talking physical, not chemical. Physical properties. We know that transition metals have got high melting points and high boiling points, but we can't say that of group 1. Group 1 have got low, clear. So it's not the same. Huh? Can you see that? Group 1 is soft, but all the other metals are hard, so it's not the same. So what is the same? Good what? Conductor of what? They are all good conductors of heat. I thought you were going to think of that. Good conductors of all metals, good conductors of heat and what? Electricity. So good conductor of heat and electricity. So they are all metals. Now, predict 2 physical properties of rubidium which are different from those of transition metals. So which ones? I actually gave you a clue. Which ones are different? Physical
They are
properties.
soft.
Soft, huh? They are soft. Clear. What else as a physical property? What else besides being soft? Oh, you guys, why are you reading your notes? What else besides being soft? They have low melting points. Melting, or you can simply say melting point and boiling point, because it's different. We're talking about the physical property. Huh? So in answering the question, you can simply say physical, boiling point, and melting point. Clear. You can actually say melting point is a point on its own. Huh? You can say boiling point is marked on its own. Clear. What else besides the 3 things? So we're saying melting point, boiling point, they are soft. What else? Didn't we say all metals are heavy except group 1? Low what? Density. They have generally low density of them compared to all the other metals. Are you reading your notes there? Was it there in your chemistry notes? There are no calculations. It's a matter of just reading. Now, when rubidium is added to cold water, a reaction takes place. Suggest the observations that would be made. Tell us. Observations. Observations. Caron, very quiet. Are you reading your chemistry? Observations? Laura? Normal? Chamberlain, what observations can we make? Can I ask you something here without not looking at your notebook? If lithium reacts with water, what observation? Can someone explain what observation? Because I gave you that. If lithium reacts with water, what's the observation? Observation when lithium reacts with water.
You observe bubbles.
Bubbles are produced.
Bubbles, what did you say the bubbles are called? Effie what?
Effervescence.
Effervescence. Effervescence because hydrogen is trying to escape. Hydrogen is formed. So you observe an effervescence altogether, but at a slow rate. Okay. It reacts steadily. You can actually see that it's an observation. Steadily producing an effervescence. What about sodium? Without looking at your book. Sodium, what did you say?
It also produces an effervescence.
Yeah, so we can simply say, if we want to combine the two, we can say a vigorous what? Effervescence. Clear?
Effervescence.
A vigorous effervescence. What can you say about potassium? It's becoming more reactive. What can you say about potassium in the same group? It's an explosive what? Effervescence. So it means the same thing to be very explosive. Rubidium there is below. So it to be a very explosive effervescence. Observation. Clear? Makes sense now?
Yes, sir.
Yeah, that's what we're talking about. Because you're adding it to water. That's as easy as that. Okay. And now, the other part we didn't talk about it. The color of the methyl orange. And I will leave that for now. So it's to do when you're doing acid, base, and salts, because what is formed is an alkaline solution. So you need to know color changes. We'll talk about that when you're doing that topic, whether you're using a pH indicator, whether you're talking of methyl orange. Now, chemical reaction comes from, look at this. If you remember group 1 in general, I said X plus H2O, we form a hydroxide in this. Why? Because group 1 forms this, the hydroxide is this. So it's 1:1. So plus what? Plus hydrogen gas. I'm saying in general. So now, then we need to put 2 there. The moment we put 2 there, we put 2 there. So that I have 4 hydrogens, 2 hydrogens, 4 hydrogens, balance. So what I'm simply doing is replacing the X now with the actual rubidium and saying RB plus 2H2O, clear? To form 1 mark is for balancing the equation. 2RBOH plus H2O, clear? Make sense?
Yes, sir.
Now, put group 1 elements. Have your, before, for those that are doing computer science, if your parents printed, I had said it by the weekend, I sent them something for computer science, like a booklet that I want them to print. They have printed. Kuda, is your father printed?
I don't think so, sir.
Okay. Put group 1 elements, whatever, okay, calcium, lithium, potassium, whatever, in order of what? Of reactivity. So can you give me the most reactive from what they have said there? You look at which one is the most reactive? Easy. Tell me the most reactive there, then we write it down here.
Easier.
Yes, that's what we said. Reactivity increases as you go down the group. And if you check the videos that I sent, there was someone who just throwing this and running away. Did you see that video that I sent you? Then followed by what? Check your vegetable. Rubidium.
Medium.
Followed by potassium.
Potassium.
Sodium.
Sodium. Then lithium.
Lithium. 1 mark for free. Now, state 1 safety measure that should be used when rubidium is added to water. 1 safety measure. when added to water, what do we do? When the rubidium is being added to water, one safety. What do you think? You guys, I sent you a video. The way you are quiet, it means no one watched that video. The video that I said Lila sent to the group, showing a reaction. Remember, these reactions cannot even be done in a lab. Huh? We said the first three, but I sent you a video where they are showing, so you should know. So what could be the safety net when you are doing this? Adding to what?
To quickly move away from the video.
Yes, you quickly move from the no. I mean from the reaction. Yes, but what do you use? Can you use a test tube? If it's so reactive, what did they use? You use a what? A tab, huh? So you use a tab, huh? You use a tab, number one. When you throw the small piece, you also throw a small piece of rubidium. Then you make sure that you are a distance, huh? Away, a meter away from that, huh? Then like what he's saying, you quickly run away. You can't do this in a lab, huh? The video I sent, so people didn't watch it. Well, that's why you are not doing these experiments. I sent so that you see that, because anyway, you can never have it in a lab. Now look at this. This is nice. Group 1 plus, then the phosphate 3 negative. Do the crossing. So you need how many rubidiums? 3 of them, huh? And 1 what? Phosphate. I just done a crossing. Clear? See why it's important to know the table that I gave you? Now, the table below shows the elements. Shows the elements in the third what? Period of the periodic table. Yeah, there. Make sure you've got your periodic table, ever. Periodic table. And I hope everyone knows that when we're talking of periods, we're talking of going like this. Huh? Third what? Period. So by third period, it means they all have 3 shells. Huh? Clear? 3 shells starting from 281, which is what? Sodium. Huh? All the way to the last one, which is 288. Huh? You're simply increasing the number of electrons, huh? Growing across. Are we together? In terms of so the electrons in the outer shell, the electrons in their outer energy level, their oxidation states, okay, and their common compounds and their melting points. Clear? Now, let's see what they're asking. Describe and explain the variations in oxidation state. They love. So it's easier. So what can you say? The oxidation states increases from what? For the first 3, increases from +1 to what? We are describing what we are seeing. Oxidation state is increasing from +1 to +1. Sorry, it's increasing from +1 to +4. Or we can say to +3. For the first 3, which are metals. Then what happens in group 4?
It gains or uses.
Group 4 now, not really gaining, it means it can have a +4 and a +3. It's behaving as a metal and a non-metal. Clear? So you can now say group 4 has got 2 oxidation states. There's a +4 and a -3. It can have 2 oxidation states. Then after group 4, you see what's happening? After group 4, you are increasing from -3 to what? To 0. After group, the oxidation state, clear, is decreasing from -3. Sorry, it's actually increasing. -3 is negative. We are increasing towards 0. So the oxidation state is increasing from -3 to 0. Are we together then? You are explaining the trends that you see in oxidation state, and we should only stick to oxidation state. That's not difficult to get 3 marks for simply describing trends. The first 3 elements, sodium, magnesium, and aluminum, are metals. Describe the structure of a typical metal. So what's the structure of a typical metal? If you don't know that, you can write that question down there. A metal has got what is known as a lattice structure, like this, positive, negative, no space between. It's called a lattice structure, and it goes on like that. A lattice structure. Clear? So in terms of, you can draw, if you're allowed to draw in an exam, of course you complete this. Then you say a lattice structure, clear, of positive and negative ions closely packed together. It's metallic bonding, closely packed together in metallic bonding. Clear? Are we together there? Metallic bonding. So that's why a metal has got a very high boiling point, because there are very strong forces of attraction between the negative and those positive ions. Clear? So you need very high energy to be able to break that. Clear? Are we together there?
Yes, sir.
Metallic lattice structure of positive and negative ions closely packed together in metallic bonding. Making sense? Hope you are writing that down. Next time you know that. So far, so good.
Yes, sir.
So once we read some of these topics here, they are not difficult. It's just to read and to understand. Now, explain. Explain. What do you think? Why is magnesium, sodium, aluminium, sodium, magnesium, and aluminum? Why are they good conductors of electricity? Why are they good conductors of electricity? Because of what? Remember I talked about the lattice structure there. So why are metals good conductors of electricity? Can someone try to explain?
So isn't it because they have strong metallic bonding?
Not really conductors of, so what's the reason? Yeah, I get you, but that is to strong metallic bonding or force of attraction is to do with the boiling when you're trying to break it. But we're talking of here conduction of electricity. So why are they good conductors of electricity? Mhm. Look at back here. Because these electrons here can freely move, these negative ions here, these electrons can freely what? Can freely move. So because it has a sea of delocalized electrons, so besides that there's electrons in between. So these, it has electrons, the electrons can freely move. The sea of delocalized electrons can freely move between the charges. Clear? So there's free delocalized electrons, a sea of delocalized electrons around the positive ions, which freely move. Clear? Are we together?
Yes, sir.
Because the electricity is flow of the electrons, by the way, flow of charge. Which element exist as diatomic molecules like this in that period? Period 3, which elements? Go back to your period 3, think which element exists as diatomic. Metals can never exist as diatomic. We're thinking of non-metals. Which one in that period 3 exists as diatomic like that?
Fluorine.
Chlorine.
Fluorine or chlorine? We are in period 3.
Fluorine.
Chlorine. We said
Fluorine.
all group 7 exists as diatomic. That's what we said. So chlorine, correct. Now, silicon has a similar structure to diamond. Explain why silicon has got a high boiling point. So the moment that they say similar to diamond, so diamond has got two forms, diamond. So the carbon exists in two forms, which you need to know in chemistry. Carbon exists in two forms. You can write that down. We have graphite and what? And diamonds.
Diamond.
So this one here is a symbol covalent bond. We'll explain the structure now. Symbol covalent bond, so it means therefore low melting point and boiling point. MP means melting point, BP boiling point. This one has got a giant covalent bond. So it means high melting point and boiling point. This one here, graphite, it's slippery. What's the spelling of slippery, by the way? Slippery, what's the spelling? You do English. So, double E.
L-I
Oh, it's
double
I.
P.
Double P. Slippery. So this one is slippery, easily slide over each other. So the layers, you can write that the layers easily, you can check in a diagram, there's a nice diagram, easily slide over each other. So because of this property, it's soft and used to make pencils. Pencils. Then it also has a sea of delocalized electrons. I'll explain, I'll draw just now. Sea of delocalized electrons. So graphite electrons, so it means it's a good conductor of electricity. Good conductor, it's a non-metal, but it's a good conductor of electricity because of that structure. Okay, good conductor of electricity. That's graphite. Okay. So diamond, on the other hand, if you are writing that down, diamond is very strong, very hard and strong, like a metal. So what do you think is used to cut things? You can write that it's used to cut even other metals. Diamond, clear? I'm sure you know that. Diamond. Now, then I need to explain in terms of diagrams, or if you, maybe some of you have done covalent bonding here. So if I'm to rub this here, which I think I've written this. Hold on. So, we haven't answered the question. I thought I need to address group 4 straight away. Now, so your graphite, you have one carbon, carbon like this. So you have got 3 carbons. So if you have got 3 carbons, because here I'm sharing electrons here I'm sharing electrons, which makes it 4. So because this needs 8 electrons, I'll have 2 pairs of lone electrons here. So so this is just like one that is bonded to another set like this. So because I've got 2 pairs of, I will have a sea of many of them if it's a whole structure. So I will have a sea of delocalized electrons. But now with the diamond, every carbon here is bonded to 4. 1, 2, 3, 4. It's bonded to 4 here, like this. Such that if it's bonded to 4, this is 2, 4, 8. I can't have a lone pair. And this one will be bonded to another 4, this one. So I don't have any lone pair. All the electrons are in bonded pairs, clear? So there is no way it can conduct electricity. Are we together? Is that making sense?
Yes, sir.
So,
Yes, sir.
And you've got diagrams in your textbook that show you what I'm talking about. Are we together? Mhm. So what makes now diamond a non-metal is if I've got a layer like this and I've got a layer down here. Between the layers here, I think your book has got nice diagrams. I've got between the layers, each layer that I'm saying C4, whatever. Between the layers there, I've got weak van der Waals forces of attraction. Clear? Of attraction. So that's what gives this non-metallic property. Are we together? Because you don't find weak van der Waals forces in metals, but it's there in your textbook. Making sense? Next one.
yes, sir.
Sodium chloride is crystalline solid with a high melting point, the salt formed. It dissolves in water to give a neutral solution. Phosphorus trichloride is a liquid at room temperature. It reacts with water to form an acidic solution. Give an explanation for the difference in these properties. 2 marks. What is the explanation for the difference in those properties? The other one is forming an acidic. The other one is forming a neutral solution. What's the difference? The difference is to do, what is sodium chloride? What type of bonding is that?
Ionic.
It's an ionic. It's a bonding between a metal and non-metal. And the phosphorus trichloride is it's a covalent bond. So ionic bonding form basic oxides. Ionic bonding form basic compounds. Basic compounds, clear? Which are alkaline in water. And most of your non-metal compounds from acidic solutions. Clear? That's the reason. Describe what could show. So what do you show? You use a what? Universal indicator to check whether something is acidic, or you use a what? You use a universal indicator or what? You can use a pH scale or red litmus paper, clear? Or what? Blue litmus paper. So to test if something is as for an acid, then an alkali. An acid turns your blue litmus paper red, blue litmus paper, red. This one turns blue, red litmus paper blue. Huh? But anyway, we'll do that topic clear on the acids, bases, and salts. Now, the next one, which is a Form 3 topic. Draw a dot and cross diagram showing bonding in magnesium oxide. Show the outer shell electrons only. So let's go to your periodic table, everyone, quickly. Magnesium, revision for your O-level, oxygen there. Can you tell me how many electrons are in magnesium periodic table? Doesn't it have 12 electrons?
Yes, sir.
How many electrons are in oxygen? Electrons in oxygen?
8.
8.
8.
8.
Let's talk of the structure, the configuration, electronic configuration. So it's 2 what? 8. First shell maximum 2. Second shell maximum 8, 2, 8, 2. Then this one is 2 what? 2, 6. Now let's draw. They say they want the outer shell only. So we ignore these 2 shells here. We concentrate with the last shell. 2 electrons here. Then we concentrate with the last shell here, which is how many electrons? 6. So anyway, I need, because a non-metal accepts electron. So this one transfers that, and this one transfers what? Transfers that. Makes sense? It's transferring the electrons, so that I'm only left with this inner shells. And because it's giving away, I form Mg2 plus ion. This one is accepting 2 electrons, I form O2. And it's 1 is to what? 1 is to 1, but this one is giving 2, this one is accepting. There's an MgO in terms of the formula. Clear? Makes sense?
Yes, sir. Yes, sir.
That's what you're talking about here.
Okay.
Do you have comments today?
Yes, sir.
What time?
At 11:30.
Oh, that's all. Comments, then EM.
Yes.
Okay. No, write an exercise for comment. Okay, choose from the following lists. Choose from the following list of gases. A gas that may be chosen once. Okay, a gas may be chosen once, more than once, or not at all. It is used to bleach wood. Okay, wood pulp. So what is that? It is used to bleach. What do you think? What do you use? What do you think? What gases do we have? For bleaching? Bleaching. We have sulfur dioxide, hydrogen, methane, carbon monoxide, ethane, and butane. So what do we use there? Is a bleaching. The thing you can use it more than once. Hmm? What do you think? The guys are quiet. Bleaching, bleaching, bleaching. So what do you think, Uda?
So can you say hydrogen?
Hydrogen for bleaching. Bleaching. Can you use hydrogen? Is hydrogen ever used for bleaching? Sulfur dioxide. Chlorine can be used for bleaching or hydrogen peroxide. So sulfur dioxide, which can also be used to preserve food. Sulfur dioxide. When burned in oxygen, the only product is water. So what is that? Is what? Hydrogen. When you say hydrogen plus oxygen, when you burn it, you only produce what? Water. Clear? Hydrogen. The rest, we'll leave it. It's organic chemistry for now. Mhm. Now, there we have done this. Halogens are a group of nonmetals in the group. They're actually giving you a clue. In group 7 of the periodic table, the reactivity of the halogens decrease down the group. Describe an experiment which shows that chlorine is more reactive than what? Than iodine. Include an equation in your reaction. So what can you do? Describe an experiment which shows that chlorine is more reactive. So what do we do? What do you do? Mhm. What do you do? But you have the notes. Then because the person says experiment, then you got confused. Didn't you talk about displacement reactions? So it means you simply set up a reaction where, for example, if you use potassium, you use a potassium iodide aqueous solution. Potassium iodide solution, you bubble through chlorine gas like this. If you bubble through chlorine gas, so you've got the iodine solution and you bubble through chlorine gas, then chlorine will displace this because it's more reactive. That's what he said, like this. Then you form this plus your iodine. As simple as that. Hmm? You simply bubble through chlorine gas in a solution, potassium iodide. Or it can be sodium iodide, it doesn't matter. Clear? That's all from the displacement reactions that I gave you. Okay, it's time, it's over. At least we recorded these guys who send them. Okay. It's time for comments. we'll do an exercise. Let's switch to comets.